Section 1.8 is algebra of functions and compositions of functions. So how do we work with more than one composition, or excuse me, more than one function at a time, and how do we manipulate and algebraically multiple functions. So there's also going to be in this section the difference quotient, and we'll wrap back to that when we get to that problem. So one of the things I included up here is I wanted to show you some notation, all right? So there are two different ways we can express these ideas that we're going to do with these functions. So on the left here is one way, right? If we see f plus g quantity of x, what that's saying is take f of x and add it to g of x, right? Similarly with the minus, the multiplication, the division. So you might see these two different notations, but they're completely interchangeable with each other. Similar thing with composition of function, right? Some people write fog, right? You see this little circle symbol. That's not a multiplication sign. That's a closed dot. That's an open dot, right? F of g of x is how that's read, but it's also f of g of x. I personally prefer the notation on the right because I just like it as a set of instructions. So when we do compose functions, we want to make sure that we're working from the inside out. You do the innermost part first, and then you work your way to the outermost part. So let's look at an example. We've got three different functions, and we want to perform the operation that we're told and then state the domain of the resulting function. So one thing you have to be careful about here, you can't just dive into the algebra and then give the domain of the resulting function. That will work a lot of the time, but not all of the time, because some of these functions by themselves already have domain restrictions. So when we find the domain of the resulting function, I'll show you what I mean. So what I would always advise doing, if you know you're going to have to find domain after you manipulate, is it might be a good idea to just find the domain of the original functions that you're starting with first. So m of x is just a line, and the domain of a line is all reals. So we have no restrictions on this function. This function, however, we can see that you can't plug 3 into it because 3 would give you 0 in the denominator. So this function's domain is all numbers except 3. The last function has a radical, and so if I plug in 5, I get 0, but if I plug in any numbers less than 5, I get negatives under here. So the domain of this function, 5's okay, but everything's got to be bigger than 5. So now let's look at part A. This says find m times n of x and then state its domain. So that is the same thing as saying take m of x and multiply it by n of x. So m of x is x minus 4. I'm going to multiply that by 1 over x minus 3. So I end up with this expression. So now, this is what I was getting at earlier, right? We're not composing these, so we're okay. But the resulting function has a denominator. The numerator's cool. It's going to accept any value, right? But the denominator is still not going to take 3. So the domain of this function is going to be all values except 3. The next one says, well, take m of x and divide it by p of x. So m of x is still x minus 4, but p of x is the square root of x minus 5. But now we've changed the structure of p of x a little bit. So the numerator here is still fine. It'll take all real numbers. But this guy, when it was by itself, well, we said 5 and anything bigger than 5 is okay. But now this radical's in the denominator. So now it's not okay to get 0 underneath it anymore. So now we have to kick 5 out. So its new domain is 5 to infinity, where 5 is not included. All right, so use the two functions below to answer the following. So we've been given two equations, and we want to know what g of f of 4 plus 1 is, right? So the first thing that I would do here is I would say, well, what is f of 4? So I'm going to rewrite the expression we were given. And then I need to know, well, what is f of 4? So that means just plug 4 into our function f of x. So 4 squared is 16. 16 minus 1 is 15. So f of 4 is 15. So now I've got g of 16 plus 1, right? So just replace that with 16. So that's g. Oh, did I do this right? Yeah, 4 minus 1 is 15, sorry. So this was 15 plus 1. There we go. So that's going to be g of 16. So now I'm going to plug 16 into g of x. So that's 2 times 16 plus 1. 2 times 16 is 32, plus 1 is 33. So I just evaluated the function at the given number, replaced that in the equation, and then simplified from there. But notice you work from the inside out. B says we'll now write a formula which defines f of 2g of x minus 1. So I would recommend doing this in stages, right? Building it from the inside out. So the first thing that I want to do is let's figure out what g of x minus 1 is. So I'm going to plug x minus 1 into g of x. So that's 2 times x minus 1 plus 1, which simplifies into 2x minus 1. Then I notice that I'm supposed to multiply the result by 2. So 2 times g of x minus 1 is just 2 times the square root of 2x minus 1. Then I'm supposed to take that result and plug it into f. So f of 2g of x minus 1, we're now going to take this and plug it into f of x. So that says all of this squared minus 1. So when I square 2, I get 4. When I square the radical, the stuff inside comes out, and then I get minus 1, and this simplifies to 8x minus 5.